Hello everyone, welcome back to my channel. I'm Vishut Ramesh and today in this video I'm going to be talking about the relationships in database management systems. So let's get started. So the introduction to relationships. Relationships in the context of database design refer to the meaningful connections between different sets of data. These relationships are vital for organizing and structuring information within a database. They help ensure data integrity, improve data searching and retrieval, and reduce data redundancy. Establishing and understanding these techniques is fundamental for effective database management and design. Definition of relationships in a database design. The key elements. In database design, relationships are established between tables or entities using common fields to link and retrieve data. These relationships are constructed based on logical and business requirements. Entity relationships. Entities in a database can be related in various ways, including one-to-one, one-to-many, and many-to-many relationships, which are fundamental to understanding database structures. Relationship types in database design is essential for maintaining data integrity and ensuring efficient retrieval of information. Degree of relationship. The degree of relationship refers to the number of entities participating in that relationship. The degree can be classified into three types: unary, binary, and ternary. Unary relationship, which is of degree 1. In a unary relationship, an entity is related to itself. This is also known as a recursive relationship. In this example, there is only one entity, which is the employee entity, that supervises another employee. Binary relationship. In a binary relationship, two entities are participating in a relation. In this example, there is a student entity and a course entity. The relationship between them could be enrollment, in which a student enrolls in the courses. Ternary relationship. In a ternary relationship, three entities are participating in the relation. Example. In this example, that there are three entities, which is the doctor, medicine, and patient. The relationship between these three entities could be prescribed, indicating which doctor prescribes a particular medicine to a specific patient. Types of cardinality ratios. Cardinality refers to the relationship between the number of rows in one table and the number of rows in another related table. The types are 1:1, 1:n, which is many, many:1, many:many. One-to-one cardinality. A one-to-one relationship where each row in the first table is related to one and only one row in the second table and vice versa. Example, in this there are two entities, which is the person entity and the passport entity. In this, each person has one passport and each passport is associated with only one person. One-to-many cardinality. In a one-to-many relationship, each row in the first table can be related to one or more rows in the second table, but each row in the second table is related to only one row in the first table. In this example, there is a surgeon department and a doctor's entity. Each department can have many doctors, but each doctor belongs to only one department. Many-to-one cardinality. In many-to-one relationship, each row in the first table is related to only one row in the second table, but each row in the second table can be related to multiple rows in the first table. In this example, there are two entities, which is a student and the college, and the relationship is joined. In this, a student joins only one college, but each college can contain many students. Many-to-many cardinality. In a many-to-many relationship, each row in the first table can be related to one or more rows in the second table and vice versa. In this example, there are two entities, which is a student and the course, and the relationship is joined. Each student can join in multiple courses, and each course can have multiple students. Participation constraints. Participation constraints in a database management system are rules that define the degree to which entities in an entity set must participate in a relationship. There are two main types of participation constraints: total participation and partial participation. Total participation. In total participation, each entity in the entity set must participate in the relationship. This means that there are no optimal entities. All entities must be related to at least one entity in the related entity set. In terms of notation, in an entity relationship diagram, total participation is often represented by a double line connecting the entity to the relationship line. Partial participation. In partial participation, not every entity in the entity set is required to participate in the relationship. Some entities may be optional and not have a corresponding entity in the related entity set. In terms of notation in an entity relationship diagram, partial participation is often represented by a single line connecting the entity to the relationship line. Enforcing participation constraints is important for maintaining data integrity. In a relational database, these constraints are typically implemented through foreign keys, ensuring that every reference to another table is valid. So let's look at an example. In this, there are two entities, which is a professor and a student. The relationship between the professor and the student is guides. The professor and the guides is partial participation, and the students and the guides is total participation. So the total participation for students. Total participation on a student side means that every student must be guided by a professor. In other words, every student is required to participate in the guide's relationship. Partial participation for